Okay, hello everyone. So welcome back. I'm going to record another question for our solution for question 17, QCAA exam, external exam paper 2021, paper 2. Now this one, before I started, just remind everyone to subscribe to the channel so that you don't miss the latest videos and updates. And also give us the thumbs up. So push to more people to view the channel. All right, thank you. We're going to start with the question. We got an object with a mass 2 kg. So was a rest, then release the rest and from the meters. So the total length of the inclined surface is 1 meter. So no frictions, so that means we ignore the frictions. So we 30-degree horizontal down a hill. So P is the Newton acting on the parallel to the plane opposite to the motion. So I'll point to that direction is upwards, travel down a hill. So now object travel down from the top. So in x meters, velocity is a v meters per second. So also we give the magnitude of the P, which is in that formula, and we need to determine what is the X when velocity is 2 meters per second. All right, so let's do that. We need to find the force vector in the net of this object, because we know if you look at the I component of the force, we'll see equal to, first we said because it's a downhill, so we got 2g times by sine 30-degree, that's the downhill. Then minus, because you have to take away the magnitude of P, because P is pull the opposite direction. So we minus the magnitude of P. So that's the I direction, but the Y direction is, our J direction is 0, so we ignore that. Also, we know when the force downhill, we also can use M equal to A. So that's Newton law. So we can say because of M is 2, A we can write down to V times by dV dx. So we're using the chain rule. So therefore, those two must be equal. Those two forces must be equal. So therefore, 2V dV dx must be equal to 2G times by sine 30 degrees half, take away magnitude of P, which is 4 divided by square root of 4 minus x squared. So we cancel 2 out. So it would be G minus 4 square root of 4x squared. All right, so we do a little bit of simplification. So we move to 2 to the other side. So become G is 9.8. So become 4.9 minus 2 of 4 square. I'll put a 2 square x squared. So now I'm going to integrate both sides. So this is a differential equation. So 2 times by 2 square minus x squared dx. All right, left-hand side obviously is half of the v squared plus equal to right-hand side 4.9x. 2 move out. Now this guy here is the, according to the formula sheet, is inverse of sine x divided by 2 plus c. So now we're going to decide what the c is. So let's substitute, because of when the object station at rest, the velocity is 0 initially. So we substitute into the formula, becomes 0 equal to 0 minus 2 inverse of 0 sine plus c. So that gives us, so this guy is 0, so c will be 0. So therefore, my velocity will be equal to 9.8 x times by 4 inverse of sine x divided by 2 inverse sine and plus 0. So that's my formula for velocity in relation to the displacement x. So I'm going to substitute some, because the question says when the v equal to 2, what is x? So we substitute into the formula, become 4 equal to 9.8. We don't know x. So we're going to use graphics calculator. So we use a graphics digital calculator to get. So I'm going to show you my graphics calculator calculation. I'll just put it previously solved. So you can see, I'll just show you one more time. So the enter the into graphic calculator. So the x is 0. Approximately 0.51 meters. So that's it. That's the, when the velocity is 2, so the distance traveled is about half a meter. So because total length of the plane is 1 meter. So halfway through. All right, thank you for watching. Please subscribe channel, and I'll see you next time. Bye.